All right, ladies and gents, this is section 4.2. We're talking about polynomial functions and their graphs. We have talked about polynomial functions a gajillion times. Polynomial just means many terms. We were just talking about quadratics a second ago. A quadratic is when you have x raised to the second power. So polynomials, we're going to have x raised to bigger powers, third power, fourth power, fifth power. You guys have heard this before, but the numbers in front of all of your variables, all of your x's, are called coefficients. All right, the number at the very end that has no x with it is your constant, and the leading coefficient is the number that's in the front. So if you're given a polynomial, this is a polynomial because it has a bunch of terms. Terms are separated by plus and minus signs. You put it first in order of exponents. We call those degrees. You want the highest degree first. So do you see how this goes? X to the fifth, then x to the fourth, x to the third, x squared, x, and then nothing. You guys see that? So once you have it in standard form, then you can answer all the questions about what's the constant, what's the leading coefficient, that's the one out in front, what's the degree, that sort of thing. So if you have questions like this, then it says state the degree, the leading coefficient, and the constant. First look and see, is this in standard form? Is the biggest exponent first, and then it goes down in descending order? Yes or no? Yes. So I would look and I'd say, okay, the highest exponent is the 4. So this would be the degree would be 4. If you were to solve this, how many zeros, how many answers would you have? 4. Good. So then the next question says, what's the leading coefficient? Well, what's the number that's in front of the biggest exponent? 2. It's not 2x, guys. It's just 2. And then what's your constant? What's that number that's all by itself?
1.
Positive 1. Good. This is easy. So in this case, your degree. What's your degree? 2. Highest exponent is 2. What's your leading coefficient? -5. Good. And what's the constant? Constant. There isn't one, so you would say 0. Here. What's the degree? What's the biggest exponent you see? So it's the 5th degree. What is the leading coefficient? -1. Very good. You don't see a number in front of that x to the 5th, so we assume it's 1. And then what is our constant? +3. Good. You guys want a bunch of those questions on your quiz?
Please.
Okay. They're not bad, right? All right. We're going to talk here about end behaviors. All end behavior means is what is happening at the end of the graph. Right? As you read this, it says, as x approaches infinity. That means as your x's get bigger, what's going on the right-hand side? Correct, you're looking at what the y is doing. And the second one says, as x approaches negative infinity. That means when I look at the left side of the graph, what is my end behavior? What's happening? So what I want you guys to see is here. End behavior means what's going on at the ends of the graph. Do you guys see? You're always going to be talking about as your x-axis, as your numbers are getting bigger, what's happening to the y's, and then as your numbers are getting smaller, what's happening to your y's. I'm going to have you guys tell me that it's falling to the right or rising to the right or falling left, something like that. And what I mean by that, do you guys see this blue graph?
Yes.
If I asked you what the end behaviors were, what is the graph doing at the ends? On the left-hand side, what's it doing? Going up or down? It's going up. What's it doing on the right-hand side? So you guys would tell me that this is rising. On which side?
Left.
Rising left and doing what? Falling right. Is that hard? No. Your end behavior means what's going on at the end. If you were going to write it in notation, you would say, as x approaches infinity, which is which way, right or left? Right, as the numbers are getting bigger. As x approaches infinity, y is approaching what? The y's are going where to where? Negative infinity. As x approaches negative infinity, when I look to the left, what's the y doing? It's going to infinity. It's getting bigger. It's going up. What do you notice about the ends of this graph?
They're arrows to the left.
They're arrows. Good. What else do you notice? What direction are they going?
Opposite angles.
They're going in opposite directions. That's going to be very important for you guys to understand, because if you're going in opposite directions, do you think this graph could be odd or even?
Odd.
Odd. Think odd, opposite. So if I gave you an equation and I said, just look at this equation, there's no graph. What is the end behavior? Look at the biggest exponent. If it's an odd number, then you're going to have one side is going up, one side's going down. If it's an even exponent, like x to the fourth is the biggest, what do you think both ends are going to do? They're either both going to go up or they're both going to go down. They're going to have the same. So look at this one. Do you think this is going to be an odd polynomial or an even one?
Even.
Even, because the direction of the arrows is the same. What are they both doing? They're both falling. They're both going down. So you guys would tell me that they're falling left and what?
Falling right.
Falling right. Good. As x approaches infinity, y approaches negative infinity. As x approaches negative infinity, y approaches negative infinity. They're both going the same direction. Here, so it's going to be an opposite or an even. Odd or even? Odd. Circle the ends. Tell me what the left-hand side is doing. Is it rising or is it falling? So we're falling what? Good. And rising. Right. That makes sense? Right? That's not crazy hard. So, having that information in hand, all right, same thing, same concept. Look at the left-hand side. When we have an odd degree, that means the biggest exponent is what kind of a number? Odd. You guys with me? Odd? Yes? Odd? 3, 5, 7. If I give you an equation and I say, what's the end behavior? You guys can tell me what the graph is doing just by looking at it. This is how we do that. The first thing you do, make sure the equation's written in standard form, and you say, is the degree odd or even? If it's odd, you're going to have one thing on the right, the opposite thing on the left. If it's even, they're going to be doing the same thing. So if I look in this case, okay, let's think about this for a second. What kind of a function is this? Is this positive or negative? If I read left to right, it's positive because it's going what? Up. So what do you think the leading coefficient, the beginning of the polynomial is going to be if it's a positive function? If it's an even function, I'm sorry, if it's an odd function and it's going up, what is the number going to be? Is it going to be positive or negative? Positive. So the way that we're going to draw little pictures to make this a little easier, I promise. But here, if I read left to right, what is this doing? So that means my leading coefficient is what kind of a number? Negative. All right, when we have even, it's so much easier. So much easier. Because if I have this, where both of my arrows are going in the same direction up, what kind of a equation do I have? It's even, but is it positive or negative? It's positive. If I look at my graph, and both arrows are going down, what kind of an equation do I have? Negative. So let's look at this. This is where you guys are going to have on your quiz. It's going to say, given this, tell me the end behaviors. Is it falling left or rising right, or what's it doing? So the first thing we're going to do is this in standard form with the highest degree first? Yes. So we look and we say, okay, let me look at the biggest exponent. What kind of a number is 2? It's even. So that means the direction of the arrows is the same. Guys, are they both going up or are they both going down? How do you know they're both going down? Because it's negative. So you would tell me that this is falling left and what? Falling right. You can tell that just by the exponent and the sign in the front. It's real easy when it's an even number. Because if it was a positive x squared, you would tell me that both left and right are doing what? Rising. So let's look here. Okay, this one's a little harder. First thing we look at is the equation in standard form highest degree first? Okay, what is that highest degree? Odd. It's odd. That means the direction of the arrows is different or opposite, okay? Is this a positive x cubed or a negative one? That means it's going to go some sort of that direction, right? You guys agree? So tell me what the end behavior is. What's going on the left-hand side of the graph? It's falling left. Rising right. Good job. And we're going to practice this a bunch, I promise. But this isn't a terribly difficult concept. You just got to be paying attention. If you're going to town on your iPad, I know you're not paying attention to what I'm doing. It's cool. What's going on here? Even or odd? Odd. That means that the arrows are going in opposite directions. So let's think for a second. If it's negative, that means it's going it's starting here and going which way? Down, right? So what's going on? On the left-hand side? So we're rising left and falling right. Does that make sense? A little bit? Okay. It's not awful. And then this, find the zeros. Guys, all that means is to do what? Solve it, factor it. That's it. So you'll have 2 questions on your quiz that says, here's an equation. Tell me the end behaviors and tell me the zeros. Right? You're going to have 4 questions on your quiz, but it's going to be a lot of different parts. So don't freak out that if you get one wrong, you fail it. Well, that wouldn't be failing, but you know what I mean. First thing we need to remember is when we are finding the zeros or factoring, we always look for the GCF first. And then you're going to factor however you need to. If there's special terms, grouping, that sort of thing. So let's do problems and then we'll be done. Literally a couple. All right, find the zeros. How many zeros should I have? 4. How do you know that? Okay. Let's tell the end behaviors. I didn't ask you to, but let's tell the end behaviors. Biggest exponent is what kind of a number? That means both of the arrows are going in the same direction. Positive, they're both going up, or they both going down? They're both going up. So you're rising right or left, my bad. You can do you should go left or right, you're right. Rising left and rising right. Very good. So now if I'm going to find the zeros, that means I set everything equal to what? And factor. The first thing I look for is GCF. Is there a letter or a number that I can take out of all 3 of these? No. Okay. So what do I do? Think about x to the 4th. What times what would give you x to the 4th? X squared. Okay, so x squared and x squared. Agreed? All right. Now, what times what could give you a negative 30 when you multiply, but a negative 1 when you add? Think about 30. It's 1 and 30, 2 and 15, 3 and 10, negative 6, positive 5. Agreed? Now what do I do? Okay, equal everything to 0. So x squared minus 6 equals 0. X squared plus 5 equals 0. Now what? Okay, so I have x squared equals 6. Here I have x squared equals negative 5. Agreed? Last step. Take if I physically put the square root on. Yes, so x equals here plus or minus the square root of 6. So you guys know the square root of 6? No? Does it break down easy? No. And then here I have x equals plus or minus what? Ooh, look at you, Pitter. I root 5. Do I have 4 solutions? Yes. Because plus or minus, this means I have x equals root 6. X equals negative root 6. This means I have x equals I root 5. This means I have x equals negative I root 5. 2 of them are what? Imaginary. And 2 of them are? Perfect. Good. Very good, guys. Let's look at this last one and then we're finito. Tell me the end behaviors of this graph. Did you say end? Okay, I hear opposite. Do you guys agree? Yes. Is this positive or negative? Positive. Guys, I still do this to this day. I just draw myself a quick little picture. It's going up. So then I can visually see, ooh, if I looked at the left-hand side of the graph, what's it doing on the left? Good. Falling left and what? Rising right. Zuniga, if you do not do well on this quiz, I'm going to be so mad at you. You are answering every single question perfectly. You can do this. You're welcome. I believe in you. I'm like your all's little cheerleader all the time, aren't I? I don't mean it to be annoying. I just actually truly believe in you guys. Well, most of you. I'm just kidding. Ah, so funny. All right, what do I do? Factoring. What's the first thing I look for?
Take X out.
Take the x out, the GCF. So the first thing I'm going to do is say, factor out an x, so I'm left with x squared minus 2x plus what? 1. Very good. Some of you guys make the mistake and put 0. It's not 0. X divided by x is 1. Cat divided by cat is 1. Angie divided by Angie, 1. Jimmy divided by Jimmy. Everybody? 1. Not Jimmy, no. All right, so now I'm left with, I have x on the outside. Can I factor this? Are there factors of positive 1 that I multiply to get positive 1, but I add to get negative 2? 1 and?
1.
Yep, x minus 1, x minus 1. So now I take each little piece and I set it equal to 0. So I have x equals 0, x equals what?
1.
Positive 1, and x equals 1. Anybody remember when you get the same zeros more than once, what that's called? Multiplicity. Yep. But at the beginning, check. What was the highest exponent you had? So that means how many zeros should you have? Did we find them all?
Yeah.
Yes, perfect. Good, very good.